Well, hello again, everybody. Welcome back. Here we are again, doing a little more physics. Uh, Doing a great job hanging in there. I'm proud of you guys. Today, we're going to talk about motion graphs number 4, and this is the last one. You made it. We're going to get through the graphs today, and then the next one will be a little bit about some math that we get from the graphs. But anyway, good job. You hung in there. So today, I have some really good news about acceleration, and then we've got to get to a couple big ideas about these graphs. So let's dive right in. A couple things. Be sure that when you're taking notes, you should probably be writing down a little more than I write down. Think of it just like a lecture. You need to be writing stuff down that I'm saying, not just what I'm writing down as well. So definitely make sure you're engaged, your brain is in gear, is engaged, and you're paying attention. So here we go. From last time, here's what we did. We took a velocity graph and we talked about its slope, and we put that down on an acceleration graph. So it's very similar to what we did from a position graph to a velocity graph. In fact, it was pretty much the same thing. Now here's the great news. All right, think about that acceleration graph down there. Okay, we see a couple different values, but they're constants. So the good news is this. In this class, you will only see constant accelerations ever. That's the only kind of problem you're going to see. What does that mean? What's that going to look like? We might have an acceleration that's constant, that's a positive number. That's not very constant. Let me see if I can get rid of that. I can do better than that, huh? All right. Let me see if I can draw a little bit more constant line. So there's a constant that's a positive number. So think about it this way. Something is speeding up. It's accelerating at a constant. We could have a negative acceleration. That means if something's going along, it would be slowing down or decelerating. We could also have a zero acceleration. Zero acceleration, so it's not speeding up or slowing down, it's going at a constant velocity. All right, let's have a look at these, and we'll see what this means. So here's what I've done. We're going to work backwards a little bit. I started with an acceleration graph, and in this case, I chose my acceleration to be positive. All right. What does that mean in our velocity graph? We're going to work backwards now. All that I know from this line, that's a positive number, that I can tell you about this graph is that the slope equals a positive number. All right. The slope is positive. Think about what that means. That means that my line is going to be tipped up. So it might go like that. It might start at 0 and go like that. It might start up here and go like, whoops. Let me get rid of that one. That's got a bend in it. So, it's going to erase all of them. I'll put them back in just a second, all right? We had a line here. We had a line here, and we're going to have a line there. I don't know where the line is. I don't know how tipped it is. What I do know is that it's tipped upwards. Okay? So, now, let's keep going. Let's move on to the next case. What if our acceleration was 0? All right. What does that tell you about this graph? See if you can do it. Pause me and see if you can tell me what it means. It's something about the slope. All righty. Here's what I get. The slope equals 0. That's all I know. Okay? So I've got a flat line somewhere. I might have a flat line up here. I suppose I could have a flat line that's at 0. I could also have a flat line down here. So my velocity could be positive but staying the same. Could be 0, or it could be negative and staying the same, as long as the slope is 0. That's what I know. Okay, next one. What happens if my slope is negative? Or, I'm sorry, excuse me, my acceleration is negative. Let me move my acceleration over here. My acceleration is negative. Okay, do this one for me. Slope is negative. Okay, draw a couple up there. All right, I don't care where you draw them. I don't care how steep they are, as long as they're all tipped down. Slope is negative. Got it? All righty. Now, here comes some fun. You're going to have to trust me just a little. Here's what we're going to do. We're going to work backwards another step all the way to our position graph. So up here, I'm going to have a graph that is x in meters. Okay, and then the time is going to go out like this. Let's have a look here. Now remember, we're always going to start with our accelerations as constants. Here we go. Mine's positive. That means draw a line on here that's tipped the correct way. I'm going to just draw one like that. I don't know if it's in the right place. I don't know if it's tipped the right amount. Doesn't matter. What I know is that's happening. So let's have a look at this. If we start and we think about what's going on at exactly that point right there, the velocity is 0, and then it goes positive, and it goes bigger and bigger and bigger. All right? So as I move up the line this way, the velocity is getting bigger and bigger and bigger. It's going faster and faster and faster. If something goes faster and faster and faster, it's going to move away more and more and more quickly. Okay, it's going to move. If someone's running away from me and they keep speeding up, they're accelerating, they move away from me more and more quickly. So here's what I get. I'm going to get some kind of curve that goes something like that. All right? It's going to curve up faster and faster and faster. All right? Here's the big idea. I have a positive constant for my acceleration. That means I have to have a positive slope, and this means I'm going to have a curve up. It's a curve that's opened up. And here's the strength, the power in this whole thing. I can go the other way. If I start with a curve up, what do I know? I know I've got a positive slope on my velocity, and I know I have a positive constant on my acceleration. Okay? Next video, this is going to become really important. Alrighty, let's move on to the next one. I'm going to go a little bit faster because we're running over on time just a little bit. So now we're going to do the one with 0. Okay, here's my x in meters and my time. And notice I put the 3 graphs right on top of each other. All right, acceleration is 0. What does that mean? Now, I want you to pause at each one of these, see if you can make a prediction. I'm just going to blast right through them, so you got to stop me a bunch of times. 0 acceleration means I have some kind of flat velocity, and it's somewhere like that. It could be above 0, it could be below 0, it could be on 0. I don't know. All right? What does that mean here? If it was flat, here the velocity is constant. So it's going at a constant speed. Work your way back up. Look at the velocity. What does it tell you? It's positive. And what does it tell you about the slope of that line? It's a positive number. So I have to be tipped up. All right? Now, can you think with me? If I had drawn my velocity as a negative number, how would my line look? It would be tipped the other way. All right, let's do, what if it was 0? It would, my velocity is 0, means my position is flat. It's constant somewhere. Could be positive or negative. Okay? Here we go. Acceleration is 0. What does that mean? That means my slope, whoops, that's a z. It means my slope equals a constant. And what does that mean? It means that just like from the one before, if we skip back over here, we would have a positive slope is, oh, I'm sorry. The slope equals constant, so now my slope equals, I'm sorry, I did that wrong. The slope isn't a constant on this one. I totally screwed up. My slope is 0. I'm sorry about that. And here, my slope is constant. That was bad, Mr. Eiler. Sorry about that. All right. Let's go on to the next one. There's my x, and there's my t. I have meters. Okay. Notice what we have here. We've got a negative acceleration. Okay? Negative acceleration means I have some kind of line tipped down. It's probably not in the right place, probably not tipped the right amount. But if you think, we have some kind of curve that's down. Okay? So, if my acceleration is a constant negative number, what does that mean up here? It means my slope is negative, which means curve down. All right, there was a lot in this video. This is hard stuff, folks. We're going to work with this a lot. Okay, so if you're feeling a little lost, don't get too uptight just yet. So what I want you to do for your video homework is right here. Hang in there, and we'll talk to you soon. Have a nice evening. Bye-bye.